Hello, welcome back to the channel. So let's continue our discussion on limiting comparison test and check whether this definite integral diverges or converges by only using limiting comparison test. So we have already covered the concepts of limiting comparison test in the last two videos. So if you have not watched my previous two videos on limiting comparison test, I'll highly suggest you to first watch those videos in order to get the full idea about what we would be doing in this video over here. So you know that in order to use limiting comparison test, you have to assume a second function first, and usually for the second function what we do is we take the behavior of f of x for large values of x, and whatever behavior our f of x will show for our large values of x, we'll take that function to be g of x function. In most cases that function is usually the best guess for our limiting comparison test. So now you can clearly notice in this case that your f of x is this expression over here, and for large values of x, you can clearly notice that the denominator approximates x to the power 5 because x to the power 5 is a faster increasing function than these two functions. And in the numerator as well, you can notice that for large values of x, this expression will approximate x to the power 4 in this case, right? So now our best guess for g of x will then be x to the power 4 upon x to the power 5, which is 1 over x in this case, right? And now once we have our g of x, we also have to check whether our g of x is greater than equal to 0. Whether your g of x is greater than equal to 0 for all values of x greater than equal to a. So a in this case is 10 over here, and we know that 1 by x is clearly greater than equal to 0 for all values of x greater than equal to 10. So this condition is also satisfied, and now we need to know whether our 1 by x, whether our g of x dx integral from x equals 10 to x equals infinity, which are the same endpoints, converges or diverges, right? In order to check whether our original function integral will diverge or converge. So we know that the integral, based on the prior knowledge from the last videos, we know that integral from 10 to infinity of 1 by x dx diverges. So this integral does not exist. So we know that this integral diverges, and since this integral diverges, it lies within the case 2 of the limiting comparison test over here, right? So now we have to calculate the limit of x tending to infinity for this expression, and if this expression exists and is also non-zero, then our f of x dx integral, which is the original function integral, will also diverge. So in this case, let's calculate limit x tending to infinity for f of x upon g of x. So let's calculate that. And in this case, our f of x is basically x to the power 4 minus 5x cube. So x to the power 4 minus 5x cube plus 2x minus 7 over x to the power 5 plus 3x plus 8. And you know that your g of x is 1 over x. So if g of x is 1 over x, we'll multiply this expression by 1 over x. So it will basically be multiplying the numerator by x. So now this would be limit x tends to infinity x to the power 5. If we multiply x with this expression, it will be x to the power 5 minus 5x to the power 4 plus 2x square minus 7x upon x to the power 5 plus 3x plus 8. And now we can take x to the power 5 common in the numerator and in the denominator. So what will happen is limit x tends to infinity x to the power 5 1 minus 5 by x plus 2 by x to the power 3 minus 7 by x to the power 4 over x to the power 5 1 plus 3 upon x to the power 4 8 over x to the power 5. And now if you'll take, so x to the power 5 will cancel, and now if you'll take limit x tending to infinity for this expression, you know that these expressions will approximate 0, and these expressions in the denominator as well will also approach 0. So then your limit, your final limit will be equal to simply 1 in this case. And now you know that the limit of x tending to infinity for f of x upon gx exists and is also non-zero because 1 is not equal to 0. So since this is the case, then we can clearly state that our original function integral, which is our f of x dx integral with the same endpoints, will also diverge. And that's what we proved by only using limiting comparison test and not using any other method that we discussed. So that's it for this video. Again, feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.